Okay, once we understand the idea of identities, we need to take a look at the fundamental trigonometric identities. Now, some of these you should be familiar with. You should be familiar with sine and cosecant, that sine and cosecant are reciprocals. Notice they're called the reciprocal identities. Tangent and cotangent are reciprocals. We've talked about the ratio identities where tangent equals sine over cosine. Okay, and tangent would then be secant over cosecant. Cotangent would equal cosine over sine. Sometimes your teachers will have you do a little exploration where you figure out one from the others here. One of the major ones here are the Pythagorean identities, and we're going to talk about those a little bit more here in a minute. But if you think back to the unit circle here, sine squared plus cosine squared equals 1. If you think about that and you remember that sine referred to your y values on the unit circle plus cosine squared, which is x squared, equals 1, then you see that that's just the equation for the unit circle. And you can make that connection probably a little more apparent in your classes. Anyway, these are huge. We end up using these a lot, and so you need to be very familiar with them. And then the identities due to symmetry. Now, all of these, what they do is they tell us that for any theta we put in here, the statement would be true. It doesn't matter what you pick. All right? So these we are going to end up using to verify other trig substitutions, and we'll get to that. But you need to be familiar with these, and as far as memorizing them, I would. It comes up a lot. Alright, so let's go ahead and use these. Identifying families. Show that the Pythagorean identities can all stem from the identity sine squared plus cosine squared equals 1. Okay, well, we're going to do that real quick here. Just takes a second. And this is more to help you not have to really memorize a bunch of these. You can kind of figure them out. So what I'm going to do real quick here is I'm going to show that this one can lead to another one of the fundamental identities by dividing both sides by sine squared theta. Okay? By the way, as a side note here, I think we should put this back up here, is that if somebody says cosine squared theta, that actually equals this. It's kind of shorthand for writing that. Those are equal. Okay, same with sine squared theta equals sine times itself. That's what that notation means. Okay, and etc. Okay, something worth noting. Okay, I'm sorry. Back down here. So we're showing how we can get these other Pythagorean identities based on this. Well, if I divide both sides by sine squared, and then I think of it this way, distribute this denominator, look at what we get. Okay. Alright, we get sine squared over sine squared plus cosine squared over sine squared equals 1 over sine squared. All I did was put this sine squared under each one of those. Okay. What I get here is a 1 plus cosine squared over sine squared. If we go up here, we'll see cotangent equals cosine over sine, and if they're just multiplied to themselves, this would be cotangent squared theta equals 1 over sine squared would be cosecant squared theta. Okay? And this is another one of our Pythagorean identities. Okay? Let's take another look at this. If I start off with cosine squared theta, that equals 1, or sine squared plus cosine squared equals 1, and I now divide both sides by cosine squared, okay, we end up with this, sine squared theta over cosine squared theta plus cosine squared theta over cosine squared theta equals 1 over cosine squared theta. And again, here, sine squared over cosine squared, if you look up in the chart, equals tangent squared theta plus 1 equals secant squared theta. And that is another one of my Pythagorean identities. So you can see here that if we work with cosine squared and sine squared plus cosine squared, we can actually get the other two Pythagorean identities from those. Okay, let's just look at this because this is going to be helpful. Just a couple variations of the Pythagorean identity. Okay, since sine squared plus cosine squared equals 1, we could also conclude just by solving for sine squared that sine squared equals 1 minus cosine squared theta, and that cosine squared theta equals 1 minus sine squared theta. Okay, these are going to be really important again for verifying trig substitution, verifying identities, which we're going to do next in the next video.